Welcome to Chapter 1, Lesson 10, on page 89. Compare real numbers. Okay, so whenever I hear compare, I'm thinking I'm going to use the less than, greater than, or equal symbols. All right, this is about baseball. Major League Baseball has rules for the dimensions of the baseball diamond. A model of the baseball diamond is shown. On the model, the distance from the pitching mound, that's here, to the home plate, here, is 1.3 inches. Is 1.3 a rational number? Okay, so think all the way back to the beginning of this chapter, chapter 1, all the way back to talking about rational numbers. Remember we talked about rational numbers. We have natural numbers, whole numbers, integers, which means it has a negative. And then rational numbers can be fractions, percents, decimals, repeating decimals, as long as they repeat in a pattern. Remember that? Okay, so it's saying on the model, is 1.3 a rational number? Yes, of course it is. It could be written as, let's see, 1 3/10, or you could say 13/10. Okay, so it can be a fraction. Remember, they have to be able to be written as a fraction where the denominator is not 0. On the model, the distance from the first base, that's here, to second base, this is first, second, is 2 inches. Is 2 a rational number? Yes. Is a whole number, or you could say a natural number. The distance from home plate to second base is square root of 8 inches. Use a calculator to find square root of 8. Does it appear to terminate or repeat? Terminate, remember, means end. All right, so I'll just say square root of 8. Okay. Well, it appears to terminate, but on the other hand, they could have just rounded that number so that because it is off screen now. So I'm just going to write that down. 2, 7, 1, 2, 5. Okay, so now it says, does it appear? I would say it appears to terminate or end. So it's looking like it's terminating. Okay, now it says to determine if the number terminates or ends on your calculator, multiply your answer, square root of 8 by itself. Do not use the x squared button. Don't use the x squared button. So basically, you're doing square root of 8, and my button will have an answer button. So that means put the answer. It just means it's transferring the answer. So it's saying don't use the x squared button. So you have to copy it in again. 2.828427125. Okay, and then my answer, no. There's a 1 at the end. So I do not think that this is a terminating decimal. No. This is not a terminating decimal. It's not a perfect square. Think about it. 2 squared is 4. 3 squared is 9, right? So square root of 8 is not a terminating decimal. It's not rational. So no, square root of 8 is not rational. it is not a repeating decimal. Look, see, there's no pattern here. 828427. It's not a repeating decimal or a terminating decimal. It's neither. Okay. All right. Oh, look, they have their chart right here. Okay. Irrational number is a number that can be expressed as the ratio A over B, where B can't be 0. So these things: integers, repeating decimals, fractions. An irrational number is a number that cannot be expressed as a ratio. Okay, but it's still real. Okay, it's still real. Now, in our one lesson, we talked about how square root of negative 100 couldn't be real. Square root of 8 is still real. It says numbers that are not rational are called irrational numbers. The square root of any number that is not a perfect square number is irrational. The set of rational numbers and the set of irrational numbers together make up real numbers. They are still real. Okay? It says name all the sets of numbers to which each real number belongs. Okay, so 0.2525. Okay, so it's 0.25 repeating. And we learned earlier in the chapter how to make that into a fraction. So this is a rational number, right? Rational number. Oops, that's the answer here. Sorry, this is for A down here. Got carried away. Okay, so since square root of 36 is 6 and 6 is a natural number, then this is a natural number, it's a whole number, and it's a rational number. So it fits all of these categories. Now, negative square root of 7, the decimal does not terminate, does not repeat, so it is an irrational number. It's an irrational number. Okay, so you have to do this on your own. Tell what does it belong to. Does it belong to natural, whole, rational, irrational? Put as many as apply. Just like this one, there was natural, whole, integer, and. It counted as all of them. Okay, so do those. We'll go over them in class with the popsicle sticks, so be ready. Okay, now we're going to be comparing and ordering. Comparing and ordering. That's when we're going to use this greater than, less than, equal sign. Okay, let's see. Well, we just talked about square root of 7, and thankfully over on this page they just told us what the decimal was. Okay, 2.6457. Okay, it's going on. And this is 2 2/3, which as a decimal is 2.6. So you can see this one is slightly larger. If you compare the 100th place, this one is just slightly larger. So square root of 7 is less than 2 2/3. Okay, now we have 15.7% as a decimal, 0.157. If we make this into a irrational number, square root, you just type square root button, and you can just do 0.02. Look, see, I got the same answer as them. They just rounded to the thousandths place. Okay, they both have 1 in the 10th place, but this one is 5 here, so that means this one's just slightly larger. Okay, now we have to order these from least to greatest, so they want the smallest one first. Okay, well, 6 is clearly the biggest one. Think about it. Because we know that 6 times 6 is 36, so it's not going to be any of these. So 6 is clearly the largest. Okay. 5 4/5 is 580. Okay, so that's going to be the second largest. Now let's see, you just do square root of 30. And they have 5.48. They just rounded it. And then this one is 5.36 repeating. So this one's slightly bigger. So it's in this. And then this one would be the smallest, 5.36 repeating. So they put from least to greatest. Alright, so then that's your job here, is to order these. Okay, first just use greater than, less than, or equal, greater than, less than, or equal, greater than, less than, or equal. And they want you to order these ones from least to greatest. And oh, look, they're all negative. Interesting. So you put them on the line like they did in this example problem, and then try putting them here. Okay, feel free to use the calculator for these. That's all right. Okay. On a clear day, the number of miles a person can see to the horizon is about 1.23 times the square root of his or her distance from the ground. Okay, so you're up there looking out with your little eyes. Okay, this is your distance from the ground, right? So you're doing it 1.23 times the square root of the distance from the ground. Okay, so Frida is at the Empire State Building observation deck at 1,250 feet. Okay, so you do square root of 1,250 times 1.23. And this, when you see the wavy line, this means approximately or about. Okay, and then Kaya, she was up 1,362 feet. So take the square root and multiply it times 1.23. And this is her estimated value. Now it says how much farther. So that means subtract. So subtract the Kaya's from Frida's. Okay. And then you'll get 1.9 miles farther than Frida. Okay, so again, you're free to use your calculator in class. All right, since the beginning of the lesson was about a baseball diamond, and I used to play softball, which is same rules as baseball basically, but just, I don't know, just a little bit different version. It used to be the sport that I would play in high school and elementary, really. Actually, it's the only sport I ever really played. Okay, so this will be the batter, but he needs a helmet going across. Okay, rounded. The helmets are round. They have a little circle here so you can still hear, even though your ears are protected. Will make his eyebrows very strained in concentration. Okay, and then of course he's at bat, so he's got, the batting stance going. And then the bat, and maybe his hands holding it. Ooh, I drew a little bit too close to his head. Okay, he's got his bat. And then we'll just make him a stick figure. He's ready for his at-bat. It's actually a pretty fun game, baseball. I don't know why it's not popular here in Thailand. Anyway, we'll be comparing and ordering real numbers in class, and I will see you soon.